Hello and welcome back. In this video we'll start section 2.3, which is on linear functions and their slope. By slope, I mean a measure of the incline of the straight line. So the slope is defined as the rise over the run, and by rise I mean the vertical change in the line. How fast is the line going up? And by run I mean the horizontal change, so the change in the x values. So here I have a line. I've picked 2 points along the line. We've got x1, y1 for the first point, and the second point will have x2, y2 as the x and y values. So we need to calculate the rise over the run. And by the rise, I mean the difference in the y values. So when we look at these 2 points, the rise is how fast or how far it has risen. So this is going to be y2 minus y1. This is the distance in height, the difference in height between these 2 points. The run is going to be essentially in the x values. So it's going to be the distance from these points here. So this is going to be the run. And again, we're going from x1 to x2. So the distance that we've traveled will be x2 minus x1. So ultimately the slope, which we normally call m, is going to be y2 minus y1 divided by x2 minus x1. A couple of things. If it doesn't matter which 2 points along the line you choose, as long as it's a straight line, you will always get the same slope. So the slope is not changing along here because it's a straight line. And then just as an aside, we use the letter M. This stands for the French word, this is the first letter of the French word monter, which means to ascend or to arise, to rise. So essentially M stands for how fast is this going up in French. So let's do a more explicit example with some numbers. So let's find the slope of the line passing through the points -3, 4, and -4, -2. So M, our slope, is going to be the difference in the y values divided by the difference in the x values. So I'm going to call my first point x1, y1, 1 for the first point, and I'm going to use 2's for the second point, x2, y2. So I'm going to take y2 minus y1 divided by x2 minus x1. So y2 is -2, y1 is going to be 4, so -2 minus 4. On the other side, we've got x2, which is -4, and x1 is going to be -3. So we're going to subtract a -3. So we'll have to be a little bit careful down here. On the top, -2 minus 4 is going to be -6. And -4 minus -3, the same thing as -4 plus 3 after the negative signs cancel out. It's going to be -1. And -6 divided by -1 is just 6. So here's my slope. It's just 6. If we graph this, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. This isn't very to scale, but hopefully it won't matter. If I graph these 2 points, so -3, 4, so 1, 2, 3, 1, 2, 3, 4. This is -3, 4. And then -4, -2, 1, 2, 3, 4. And then down to 1, 2. So this is a pretty steep line. It goes up quite rapidly. So our slope is going to be 6. Okay, so this is a line with slope 6. Please forgive the poor drawings. And then the slope of line passing through the points 4, -2, and -1, 5. Again, we can do this in exactly the same way. We'll call our first point x1, y1, our second point x2, y2, and we can find the slope, which will just be y2, which is 5, minus y1, which is -2. We'll take x2, which is -1, minus x1, which is 4, and we'll get 5 minus a -2, so that's the same thing as 5 plus 2 after we cancel out the negative signs. It's going to be 7. And on the bottom, we've got -1 minus 4. Well, that's -5. And this doesn't simplify at all. If we wanted to, I could pull out the negative sign and say that this is going to be -7/5, but ultimately, this is my slope. So when we look at different kinds of slope, we'll get different sorts of numbers. For an increasing function, both the rise and the run are going to be positive numbers. We're going up and we're going to the right, so our slope is going to be positive. When we're decreasing, when we have a decreasing line, the rise is now going to be negative because we're going down, but we still move to the right, so we have a positive run. So a negative number divided by a positive number is going to be negative. So we'll have a negative slope. For a constant function that's moving from right to left at a level pace, there is no rise anymore. The rise is going to be 0. Even though we're moving to the right, so we'll have a non-zero run, the rise is 0. And 0 divided by anything is 0. So the slope of a horizontal line is 0. And a vertical line, this is where things get a little bit interesting. First of all, if we use the vertical line test and we draw a line through it, well, it's going to intersect it in more than one place. So right away, we know that a vertical line is not a function. So this is something that's not even a function. It's still a line, though. We can still describe it. And then we might try to calculate its slope. Well, with its slope, the rise, well, it's going to go up, so it has a positive rise. But the run, how far it changes from left to right, it doesn't. So we're going to have a slope that's going to be a positive number divided by 0. Well, we can't divide by 0. So the slope, m, is undefined. You might see this referred to as having infinite slope. It goes up infinitely far for how far you go from left to right, but this is a better way of phrasing this. You can have a slope that's positive, negative, or 0, or in the special case of having a vertical line, we say that the slope is undefined. So with all of this, now that we have slope, we can write down an equation for a line that's given to us. So depending on what kind of information is given to us, we can write down equations that look different. So the first equation that we're going to look at is what's called the point-slope form. Why is it called point-slope form? If you're told a point that the line passes through, and you're told the slope, as in you're told a point and the slope, we can write down this equation. So this equation is worth memorizing. It is very important, and it is, in fact, very easy to use, as we'll see in a couple of examples. Now, before I do any examples, when we look at this, we have y minus y1, so this is y minus the y coordinate of the point, is equal to m, which is the slope, times x minus x1, and x1 is the x coordinate of the point it passes through. So we can just plug in here, we've got our point x1, y1, and our slope m. If you solve for m, if we solve for the slope, I'll just divide both sides by x minus x1, and this is meant to be a 1 here. And what we have looks a lot like the original formula for the slope, which is going to be the rise, how much y changes, over how much x changes, the run. So this is where this formula comes from. It comes directly from the formula for slope. So let's apply this. Let's just use this formula to come up with an equation for a line. So let's find an equation of a line in point-slope form for the line with slope 6 passing through the point 2, -5. So our formula is y minus y1 is equal to m times x minus x1. So our point here, I'm just going to call this our x1, y1. So we have all the ingredients. We know y1 and x1, and we know m. So we can just plug it in. So our formula is going to be y minus y1, which is negative 5, times m, which is 6, times x minus x1, which happens to be 2. So here's the equation for the line that passes through this point. This question, and quite often questions will ask you to solve for y. This is simply because it's a little bit easier to see, to understand the equation quite often when it's solved for y. So right away we'll see that y minus negative 5 is just y plus 5. I'll distribute the 6 on this side, so we'll have 6x minus 12. And then I'll subtract 5 from both sides to get y is equal to 6x, and negative 12 minus 5 is negative 17. So here's point-slope form. Here is the equation solved for y. And I do want to quickly draw a picture of what this looks like. And I can draw this picture without having to use these equations. I can just use the point and the slope. So if we come out to 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This line passes through this point, so let me find this point. 1, 2, 1, 2, 3, 4, 5. And it has slope 6. And remember that the slope is going to be rise over run. And 6 is the same thing as 6 divided by 1. So for every 6 we go up, we go 1 over. So if we go up 6, 1, 2, 3, 4, 5, 6, and we go over 1, this will be the next point in the line. So if I could draw a straight line, this is what the line would look like. So again, it goes up 6 and over 1 for a slope of 6. So we can draw this line without knowing the equation, but the equation is also helpful. Let's do one more example. Let's find the equation of the line in point-slope form that passes through these 2 points. So in order to use point-slope form, we need a point. Well, we've got one, but we also need a slope, and we don't know the slope yet. So we just have to calculate it. So let's call our first point x1, y1, and our second point x2, y2. So when we calculate slope, it's going to be the difference of the y values, the rise. So I'll take negative 6 minus negative 1, y2 minus y1, over x2 minus x1. And when we do this, we'll get negative 6 plus 1 after those cancel out. So we'll get negative 5. And we'll have negative 1 minus a negative 2, so that becomes plus 2, so this is going to be 5. So our slope is going to be negative 5. So now I have my slope and a point, and I can plug this into my formula. Y minus y1 is equal to our slope, which is negative 5, times x minus x1, which is going to be negative 2. So we have our point-slope form. Then it asks us to solve for y, so we can do that. This will simplify. Minus a negative 1 is the same thing as plus 1. I can distribute here, so I've got negative 5 times x. Minus negative 2 is the same thing as plus 2, but we're taking all that times negative 5, so it ends up negative anyway. I've got 3 negative signs. And then when I subtract the negative 1, I get y is equal to negative 5x. Negative 10 minus 1 is negative 11. And this is the point-slope form, and this is our equation solved for y.